Hello and welcome to Science for Bedtime. I'm glad you're here, in this quiet stretch of time where curiosity doesn't need to rush and understanding doesn't need to be complete. Tonight, science can be something gentle. Not a puzzle to solve and not a lesson to remember, but a calm companion as your thoughts begin to slow. You don't need to follow every idea closely. You can simply listen, letting the words drift by while the universe quietly does what it has always done. Above you, beyond walls and roofs and clouds, space continues its vast, patient unfolding. The night sky looks calm, almost still, but it is anything but empty. Light travels through it endlessly, carrying information from places so distant that their journeys began long before human history. Some of the light reaching Earth tonight left its source millions or even billions of years ago, moving steadily through space without knowing whether it would ever be seen. This alone is one of the universe's quiet mysteries. Space is not just a backdrop where things happen. It is an active participant. It stretches, bends, and carries energy. According to modern physics, even what we call empty space is never truly empty. It holds faint fluctuations, subtle fields, and a structure that shapes how matter and light behave. Nothingness, it turns out, is gently busy. When astronomers point their telescopes outward, they see galaxies arranged in vast patterns. These are not random scatterings, but delicate filaments stretching across immense distances, forming what scientists call the cosmic web. Galaxies gather along these invisible threads, leaving enormous voids between them. The universe, on its largest scales, resembles a softly glowing network suspended in darkness. What holds this structure together is one of the greatest mysteries in modern science. Galaxies rotate faster than they should. Clusters remain bound when visible matter alone cannot explain their stability. Something unseen provides additional gravity, shaping the universe without revealing itself directly. This presence is known as dark matter, not because it is ominous, but because it does not interact with light. Dark matter does not glow, absorb, or reflect. Telescopes cannot see it, yet its influence is unmistakable. It gently pulls on galaxies, bends light passing nearby, and provides the hidden scaffolding that allows cosmic structures to form. Without it, stars and galaxies might never have gathered in the first place. The universe would be smoother, quieter, and far less structured. Even so, dark matter remains elusive. It passes through ordinary matter almost without notice, interacting primarily through gravity. Experiments deep underground search for rare encounters between dark matter particles and atomic nuclei, but so far, these detectors have remained quiet. The mystery persists not as a failure of observation, but as an invitation to deeper understanding. Light itself offers another subtle wonder. Though it feels instantaneous, light has a finite speed. When you look at the moon, you see it as it was just over a second ago. When you look at the sun, you see it as it was 8 minutes in the past. Distant galaxies appear not as they are now, but as they were when the universe was young. Every glance into space is also a glance into time. This means the universe presents itself as a layered history, with nearer objects revealing recent moments and distant ones revealing ancient epochs. Astronomers read this light like a quiet archive, piecing together the story of cosmic evolution. The universe remembers its past not through records, but through motion, structure, and radiation still traveling through space. One of the oldest signals we can detect is the cosmic microwave background, a faint glow that fills the entire sky. It is the cooled remnant of the early universe, released when space first became transparent to light. This radiation is remarkably uniform, yet it contains tiny variations that later grew into galaxies and clusters. From near-perfect smoothness, complexity slowly emerged. These small irregularities matter. Without them, matter would never have gathered. Gravity needs something to work with, however slight. Over billions of years, those faint differences were amplified, shaping stars, galaxies, and eventually the environments where planets could form. The universe did not begin as detailed and complex. It began simple and allowed time to do the rest. Time itself behaves strangely on cosmic scales. According to Einstein's theory of relativity, time is not the same everywhere. It flows differently depending on speed and gravity. Near massive objects, time slows. In the vast emptiness between galaxies, it moves slightly faster. These differences are usually too small to notice, but they are real and measurable. This means the universe does not share a single universal clock. Each region carries its own rhythm, shaped by motion and mass. Yet despite this, the cosmos remains coordinated. Physical laws hold across enormous distances, allowing atoms, stars, and galaxies to behave in familiar ways wherever they appear. Another mystery lies in the universe's expansion. Space itself is stretching, carrying galaxies away from one another. This expansion was discovered in the early 20th century and has been confirmed again and again. But what surprised scientists later was that this expansion is accelerating. Something is pushing space to grow faster over time. This influence is called dark energy. Like dark matter, it is known only through its effects. It does not clump or gather. Instead, it seems to be woven evenly into space itself, exerting a gentle pressure that becomes more important as the universe grows larger. Over time, it may shape the ultimate fate of everything. If dark energy remains constant, distant galaxies will slowly fade beyond reach. Their light will never arrive. The universe will become quieter and more isolated, not because stars disappear all at once, but because space stretches too far between them. This future is calm, vast, and difficult to imagine fully. Closer to home, gravity still gathers matter into remarkable forms. Stars shine because gravity compresses their cores until nuclear fusion ignites. For millions or billions of years, stars balance inward pull with outward energy, glowing steadily. When that balance finally ends, stars change, sometimes gently, sometimes violently, enriching space with heavier elements. From these processes come planets, chemistry, and eventually life. The atoms in your body were forged in ancient stars, scattered by explosions long before the sun formed. The universe recycles itself, turning endings into beginnings across immense spans of time. Some objects represent gravity pushed to its limits. Black holes form when massive stars collapse so completely that nothing can resist their inward pull. Around them lies a boundary called the event horizon, beyond which return is impossible. These regions challenge our understanding of space and time, revealing where current theories begin to break down. Yet, even black holes are not entirely silent. They influence their surroundings, shaping the motion of nearby stars and gas. Collisions between black holes send ripples through space-time itself, waves that can now be detected on Earth. These signals arrive long after the events that created them, gentle vibrations from distant, powerful moments. All of these mysteries share something in common. They are not loud. They do not announce themselves. They unfold slowly, governed by simple principles applied across extraordinary scales. The universe does not hurry. It allows complexity to arise through patience and repetition. And you don't need to hold all of this clearly in mind. These ideas are not here to be solved tonight. They can remain softly open like distant stars partly hidden by clouds. Understanding can come later or not at all. The universe is not offended by incomplete attention. For now, it continues exactly as it always has, expanding, forming, drifting, and evolving, whether or not anyone is watching. The universe carries on its slow unfolding through processes that are both vast and precise. On the largest scales, Gravity shapes the motion of entire galaxies. On smaller scales, it governs the orbits of planets and the delicate balance that keeps stars burning steadily for billions of years. Gravity does not hurry, it acts consistently, accumulating its effects over time, allowing structures to emerge gradually rather than all at once. Within galaxies, stars are born in cold, dense clouds of gas and dust. These regions drift quietly for millions of years, barely noticeable against the dark background of space. Over time, small irregularities cause certain areas to grow denser than others. Gravity takes hold, drawing material inward. As the cloud contracts, it begins to spin, flattening into a disk. At the center, pressure and temperature rise until a new star ignites. This process is not violent at first. It is slow and patient. Most of a star's life is spent in stability, gently converting hydrogen into helium through nuclear fusion. Energy flows outward, balancing gravity's inward pull. Light leaves the star and travels into space, carrying with it information about the star's temperature, composition, and age. Stars differ greatly in size and lifespan. Smaller stars burn their fuel slowly and can shine for trillions of years. Larger stars live fast and end dramatically, sometimes in powerful supernova explosions. These explosions scatter heavy elements into surrounding space, enriching future generations of stars and planets. Without this recycling, complex chemistry would be rare. Around some stars, disks of leftover material gather into planets. Dust grains collide and stick together, forming larger bodies over millions of years. Gravity organizes these objects into orderly orbits. Some planets remain rocky and dense, others grow massive and accumulate thick atmospheres. Each planetary system reflects a unique history shaped by distance, timing, and chance. Our own solar system carries the marks of this long formation. The planets orbit in nearly the same plane, remnants of the original disk. Asteroids and comets preserve ancient material, largely unchanged since the system's earliest days. Even now, small pieces occasionally fall to Earth as meteorites, quiet messengers from deep time. Beyond individual systems, galaxies themselves evolve. They merge, stretch, and change shape over billions of years. Spiral arms form and dissolve. Star formation slows as gas is used up or expelled. Some galaxies become calm and sparse, filled mostly with older stars. Others remain active, still forming new ones in glowing clouds. Galactic centers often host supermassive black holes, millions or billions of times the mass of the Sun. These black holes grow slowly, feeding on nearby gas and stars. When actively feeding, they can outshine entire galaxies, releasing enormous amounts of energy. When quiet, they remain nearly invisible, influencing their surroundings through gravity alone. Despite these dramatic possibilities, most of the universe is calm. Vast regions contain only thin traces of gas and a few wandering particles. Light crosses these spaces without interruption for millions of years. The universe is not crowded. It is mostly open, with islands of matter separated by enormous distances. Time in the universe flows with a steadiness that can feel almost abstract. Events unfold across scales far removed from everyday experience. A single human lifetime is brief compared to the life of a star, and vanishingly small compared to the age of the universe itself. Yet the same physical laws apply at every scale, connecting the smallest moments to the largest structures. Even on Earth, this cosmic rhythm leaves subtle traces. The elements that make up oceans, mountains, and living cells were forged under conditions far more extreme than anything found today. Their presence here is the result of countless prior events layered one upon another, with no single moment responsible for the whole. The night sky offers a quiet reminder of this continuity. Constellations appear fixed, yet over long periods they slowly change as stars move through space. Given enough time, familiar patterns dissolve and new ones form. Stability is always temporary, maintained through balance rather than stillness. Astronomers study these changes using light across many wavelengths. Visible light reveals stars much like our Sun. Infrared light shows cooler regions where stars are forming. X-rays and gamma rays expose the hottest and most energetic events. Each window reveals a different aspect of the same universe, layered rather than separate. None of these observations suggest a universe rushing toward a conclusion. Instead, they reveal a system that changes steadily, responding to its own conditions. Expansion continues, structures form and fade, energy spreads out, complexity rises in some places and diminishes in others. This steady progression does not require guidance or intention. It follows from simple rules applied consistently over time. Gravity attracts, energy moves from concentrated to dispersed, matter organizes where conditions allow. From these principles, an astonishing variety of forms emerges. You do not need to hold all of this in focus. These ideas can remain gently open like distant lights seen through a window. The universe does not require attention to proceed. It continues whether it is studied closely, imagined vaguely, or not considered at all. What matters is that it continues. Stars form, space expands, light travels, patterns shift slowly, almost imperceptibly, across spans of time far longer than any single perspective. And within this vast setting, nothing feels urgent. The universe does not hurry its next step. It allows processes to unfold fully, shaped by patience rather than speed. This long, steady unfolding is not distant from everyday life. It is the context in which everything exists. The same physical principles that guide galaxies also govern atoms, chemistry, and motion closer to home. There is no separate universe for the large and the small, only different scales of the same quiet order. For now, this order remains, extending outward in every direction, holding stars in place, carrying light across space, and allowing time to pass in its own unforced way. Within that order, change is never abrupt. It arrives gradually, layered over what came before. Even the most dramatic events in the universe are prepared for long in advance by slow shifts in balance. A star does not suddenly exhaust its fuel without warning. Its core composition changes over millions of years, pressure and temperature adjusting quietly until a new phase becomes inevitable. When stars finally reach the later stages of their lives, they do so according to their mass. Smaller stars cool and fade slowly, becoming dense remnants that radiate heat long after their light has diminished. Larger stars expand, shedding their outer layers into space, forming glowing shells known as planetary nebulae. These clouds drift outward, enriching the surrounding region with elements formed deep inside the star. In some cases, the collapse of a massive star's core is so complete that not even light can escape. What remains, it is a black hole, defined not by substance, but by gravity itself. Despite their dramatic reputation, black holes are governed by the same predictable rules as everything else. They grow only by what falls into them, and they influence their surroundings without intention or awareness. Over immense spans of time, even black holes change. According to current understanding, they slowly lose energy through subtle quantum effects, evaporating far more gradually than any familiar process. Nothing in the universe is truly static. Change is simply paced according to scale. As the universe continues to expand, galaxies drift farther apart. The light from distant regions stretches, shifting toward longer wavelengths. Over time, fewer galaxies will remain visible from any single point in space. This does not signal an ending, but a thinning, a quiet spreading out of what already exists. Yet even in this future, local systems remain active. Stars continue to orbit within their galaxies. Planets continue their paths around stars. On worlds where conditions allow, chemistry continues to explore complexity, forming structures that persist for a time before changing again. Seen from this wider view, one of the most striking features of the universe is not how crowded it is, but how much space there is between things. Distance in the universe is not an obstacle or an inconvenience. It is a defining characteristic. Most of what exists is separated by vast, quiet stretches where very little happens at all. The closest large object to Earth is the Moon. It appears near and familiar, bright enough to feel almost within reach. Yet even this short cosmic distance carries a sense of separation. Light takes time to cross it. When you look at the Moon, you are not seeing it as it is in that exact moment, but as it was just a little while ago. Even here, stillness and delay are already present. Between Earth and the Sun, that separation grows more pronounced. The Sun dominates our sky and sustains life, yet it remains suspended at a distance where space itself fills most of the relationship. Light leaves the Sun and travels outward, crossing emptiness before it arrives. That journey is steady and uninterrupted, a reminder that even the closest cosmic connections are mediated by space. Within the solar system, this pattern continues. Planets follow wide, patient paths around the Sun, separated by expanses that dwarf the objects themselves. Most of the solar system is not planets, moons, or asteroids, but open space through which light and particles move freely. Motion here is orderly, but never crowded. Beyond the outer planets, the solar system fades gradually into interstellar space. There is no sharp boundary, no wall or edge. The influence of the Sun weakens, and the space between stars becomes dominant. This region is not empty in an absolute sense, but it is sparse. A few atoms drift, magnetic fields stretch thin, light passes through almost untouched. The nearest stars are separated from us by distances so large that the solar system itself becomes a small island in a much larger sea. These stars are not arranged closely together, but scattered, each with its own surrounding space. From one star to the next, light travels for years, crossing darkness that contains little more than faint traces of gas and dust. And yet all of these stars belong to the same structure. The Milky Way is not something you look at from the outside. It is the space you already inhabit. A vast, rotating collection of stars, planets and clouds spread across distances so great that even moving at the speed of light, it would take an immense span of time to cross from one side to the other. Within the Milky Way, stars orbit slowly around a shared center, each following a path shaped by gravity and time. From inside, this motion feels almost static. The galaxy changes, but on timescales so long that stability becomes the dominant impression. What looks fixed is simply moving very slowly. When you look up at the night sky, the stars appear close together, forming familiar patterns. But those patterns are a matter of perspective. Each star sits at its own distance, separated from its neighbors by vast stretches of space. The apparent closeness is an illusion created by viewing from one small point inside the galaxy. Distance, in this sense, is not something to overcome. It is part of how the universe maintains its calm. Space prevents constant interaction. It allows systems to evolve without interference. Stars can burn for billions of years because they are far apart. Galaxies can persist because collisions are rare. Even on the larger scales, this quiet separation continues. Galaxies gather into clusters, clusters into larger structures, but between them lie enormous regions where almost nothing happens. Light crosses these regions without resistance. Gravity acts gently across them. The universe expands not by filling space with more matter, but by allowing space itself to stretch. From within it, this vastness does not feel dramatic. It feels steady. Distance softens urgency. Events unfold slowly, buffered by space. Cause and effect are separated not only by time, but by the long journeys signals must make to travel between places. This scale changes how the universe behaves. Nothing happens all at once. No event instantly affects everything else. Information moves at a finite pace. Change spreads gradually. The universe remains coherent not because it is tightly connected, but because it is loosely bound across immense distances. In this way, space itself becomes a stabilizing presence. It holds objects apart just enough to allow complexity to develop without constant disruption. It creates room for stars to form, for galaxies to evolve, and for light to travel quietly across the dark. And from where you are, inside one small part of this vast structure, that distance is not something you need to measure or imagine precisely. It is enough to recognize that the universe is large, open, and unhurried, shaped as much by the spaces between things as by the things themselves. Across these vast separations, almost everything we know about the universe arrives in the same quiet way. It travels not as a sudden burst, but as a steady messenger. Light does not appear instantly, it moves patiently, carrying with it traces of where it has been. When a star shines, it is not sending a moment into space, it is releasing countless photons, each one beginning a long journey outward. These photons do not know where they are going or whether they will ever be received. They simply move at a constant speed through whatever space lies ahead of them. Some of this light reaches nearby planets quickly. Other portions travel for years, centuries, or far longer, passing through regions where nothing interrupts their path. Along the way, the universe does not hurry them. Space offers no resistance, only distance. Because of this, light becomes a kind of memory. When it finally arrives, it carries information from the moment it was released. The brightness, the color, the subtle patterns within it all reflect conditions at its source. Looking outward, we are not seeing objects as they are now, but as they were when their light began its journey. This layering of time into light happens automatically. No effort is required to look into the past. Distance does the work on its own. The farther light has traveled, the older the information it brings. The universe presents its history openly, not through records or archives, but through motion that never stopped. As light crosses expanding space, it changes slightly. The space it moves through stretches, and with it, the light itself. Its wavelength lengthens, shifting toward the red end of the spectrum. This effect is subtle but measurable, and it tells a quiet story about how far the light has traveled and how much the universe has changed along the way. This stretching does not damage the light, it simply carries the imprint of its journey. Light from distant galaxies arrives softer, redder, and fainter than when it left, not because it has weakened, but because the space between has grown. In this way, expansion becomes visible without needing explanation. Redshift is not a signal sent intentionally, it is a consequence of travel. The universe does not label its distances or announce its age. It allows light to accumulate that information naturally, step by step, as space continues to unfold. Because of this, telescopes do not just look far away, they look back in time. Nearby stars appear recent, distant galaxies appear young. Extremely distant regions reveal the universe in its early stages, long before familiar structures had fully formed. All of this happens without effort or intent. There is no special technique required to see the past. Simply by observing light, we receive it. The universe remembers itself through motion, preserving its history in signals that are still on their way. Even now, countless photons are passing through the space around you, on journeys that began long before Earth existed. Some will continue far beyond it, never interacting with anything at all. Others will arrive at telescopes, sensors, or eyes, completing paths that took unimaginable spans of time. In this sense, the universe is never fully present. It is layered. Each direction you look holds a different moment. The sky is not a single time, but many times overlapping, arranged by distance rather than sequence. This does not make the universe fragmented. It makes it patient. Events do not vanish when they pass. Their light continues, carrying traces of what once was, moving steadily through space long after the moment itself has ended. And so, without trying to remember, the universe does. Not through intention, but through persistence, through light that keeps going, long after its source has changed, carrying with it the quiet record of a cosmos that never stops unfolding. What light reveals is not only where things were, but how they began to differ. When we look far enough back in time toward the earliest visible stages of the universe, we see something surprising. Almost everything appears nearly the same in every direction. Temperature, density, and energy are distributed with remarkable uniformity, and yet they are not perfectly uniform. Within that early smoothness were minute variations, differences so small they would have seemed insignificant at the time. Slightly denser regions here, slightly thinner regions there. These irregularities were not patterns and they were not planned. They were the natural outcome of physical processes unfolding in a young, expanding universe. At first, these differences did very little. Space was hot, matter was spread thin, and gravity's influence was gentle. But gravity has a defining characteristic. It amplifies imbalance. Wherever matter is even slightly more concentrated, gravity pulls a little more strongly. Over time, that small advantage grows. This amplification does not happen quickly. It unfolds across immense spans of time. Regions that begin just barely denser than their surroundings attract nearby matter, slowly, steadily, without urgency. As they grow, their gravitational influence increases, drawing in more material, deepening the contrast. Meanwhile, regions that start out slightly less dense give up matter more easily. Over time, this creates separation. Not through forceful division, but through gradual preference. Matter drifts toward what is already heavier. Space between becomes emptier by comparison. From this process, structure emerges. What began as almost perfect uniformity slowly transforms into a universe with texture. Dense regions become the seeds of galaxies and clusters. Less dense regions expand into vast cosmic voids. Filaments form where matter flows along gentle gravitational pathways, connecting larger structures across enormous distances. At no point does the universe decide where galaxies should go. There is no blueprint, no guiding hand arranging matter into patterns. The organization arises naturally from simple rules applied consistently. Gravity pulls, matter responds. Time allows small differences to matter. This is why cosmic structure looks both ordered and irregular. Galaxies are not arranged in neat grids, yet they are not scattered randomly either. Their distribution reflects history rather than design. Each structure carries the memory of countless tiny imbalances that were slowly magnified. Even within galaxies, the same principle applies. Slight differences in density within gas clouds determine where stars will form first. Those early stars influence their surroundings, shaping later generations. Complexity builds layer by layer, each step dependent on what came before, but not aiming toward a predetermined outcome. What emerges from this process is not precision, but coherence. The universe becomes structured without being symmetrical. It develops form without following a plan. Stability arises not from perfection, but from the amplification of variation over time. This slow organization explains why the universe feels calm on large scales. Structure takes time to develop, and once established, it evolves gradually. Nothing snaps into place, nothing rearranges suddenly. Change is distributed across space and time, softened by distance and delay. In this way, the universe demonstrates a quiet principle. Order does not require intention. Complexity does not require direction. Given enough time, even the smallest differences can shape the largest structures simply by being allowed to persist and grow. And so the universe we see today, filled with galaxies, clusters, and vast empty spaces, is not the result of design, but of patience. a long, steady unfolding where tiny irregularities were given time to matter and gravity was allowed to do what it always does, pull gently, persistently, until structure slowly emerged. Once structure has formed, it does not remain fixed. The universe continues to change, not through sudden disruption, but through ongoing expansion. Space itself keeps stretching, carrying galaxies gradually farther apart. This motion is not driven by explosions or forceful separation. It is simply the continuation of a process that began long ago and has never stopped. As galaxies drift away from one another, the distances between them grow slowly. Light takes longer to cross the space between. Over time, many galaxies will move beyond the range where their light can ever reach one another again. From any single location, fewer distant systems will remain visible, not because they have vanished, but because space has quietly widened between them. Within galaxies, change proceeds at a different pace. Stars continue to form where gas remains available, though at a slower rate than in the past. Much of the easily accessible material has already been used. New stars appear less frequently, and stellar populations gradually shift toward older, cooler stars that burn their fuel carefully over long spans of time. Individual stars follow predictable paths. Smaller stars persist for trillions of years, shining steadily and fading almost imperceptibly. Larger stars complete their lives more quickly, leaving behind dense remnants that cool slowly. Over time, bright stellar regions become calmer, dominated by long-lived faint light rather than bursts of brilliance. There is no sudden ending written into this process. Stars do not extinguish all at once. Galaxies do not collapse into chaos. Instead, activity spreads out over longer intervals. Events that were once common become rare. The universe does not break, it thins. As expansion continues, the background of space grows colder. Energy becomes more evenly distributed. Large-scale motion slows as matter spreads farther apart. This is not decay in the dramatic sense, but a gradual smoothing, a settling into wider spacing and longer timescales. Even in this quieter future, structure does not disappear entirely. Local systems remain intact for immense periods. Stars continue to orbit within galaxies. Planets continue their paths around stars. On suitable worlds, chemistry remains active, exploring complexity wherever conditions allow. What changes most is the frequency of interaction. Encounters become less common. New formations take longer to arise. Light travels through greater emptiness before meeting matter again. The universe grows more spacious, more diffuse, and more still. This future contains no collapse, no final event, and no moment of failure. It is shaped by continuity rather than conclusion. The same physical principles remain in place, guiding motion and interaction just as they always have, but with more room between each occurrence. In this way, the universe's long future mirrors its past. It is defined not by endings but by persistence. Expansion continues, stars age, space stretches, and across vast intervals the universe becomes quieter, not because something has gone wrong, but because time has been allowed to do what it does best: extend, soften, and carry everything gently forward. Across all of this, one quality remains unchanged. Nothing in the universe moves with urgency. Processes unfold at their own pace, guided by balance rather than demand. Expansion does not rush. Stars do not hurry toward their final states. Change arrives slowly enough that it blends into continuity. The universe does not require observation in order to proceed. It does not wait for attention or depend on awareness. Galaxies drift, light travels, and space continues to stretch whether it is noticed or not. These motions are not performances, they are simply what happens. There is no moment that must be anticipated, no threshold that must be crossed. Each state gives way to the next without announcement. What exists now continues into what comes after, shaped gently by the same principles that have always applied. Gravity pulls where it can, energy spreads where it will, time carries everything forward evenly. In this wider setting, individual moments lose their sharp edges. They become part of a much longer flow, one that does not need to be followed closely to be understood. It is enough to know that it continues, steady and reliable, without asking anything in return. Thoughts can move the same way. They do not need to resolve or organize themselves. They can appear, drift, and fade, much like distant light crossing empty space. Nothing needs to be held in place. Nothing needs to be completed. The universe has always allowed room for stillness, between stars, between galaxies, between events. That spaciousness is not emptiness, but balance, a quiet openness where motion continues without pressure. And so everything carries on, space expands, light moves onward, time unfolds without resistance. There is nothing here that needs to be managed, nothing that calls for effort. The universe remains patient, expansive, and calm, continuing in its own way, leaving plenty of space for rest.